So hi everyone, I'm Russell Wolf. I'm a developer at TouchLab doing Kotlin multi-platform stuff, as well as a Google developer expert in Kotlin. Yeah, thanks for coming to the Swift Kotlin Boundary. Before I jump in, by the way, you do have the ability to turn your camera on if you want, and I have the gallery view up on the side so I can kind of see the audience as if I was in a real conference. So if you want to give me that experience, you can turn your camera on, but don't feel like you have to if you don't want to. But in any case, I will get started. So this is the Swift Kotlin Boundary. We all know Kotlin as is more than just a language, excuse me. We all know Kotlin is more than just an island in Russia. It's a programming language that's obviously largely used by Android developers, but it's also used on the JVM. It has a target to JavaScript, where it can be used in the browser or in Node, and it's usable. It has a native target via LLVM, which we interop with C APIs and enables iOS interop by Objective-C, or enables use on iOS by Objective-C interop. And bringing all of those together is Kotlin Multiplatform, which lets you compile Kotlin code to multiple of those different targets, as well as having platform-specific code, which interops with the individual platforms. And what that gives you in total is this really nice flexible cross-platform story where you can share the code that makes sense to your use case, but you're not blocked from making use of any of the per-platform niceties that you're used to in your native code. So I work with Kevin Galligan, who used to always put this slide in his talks and then make a joke about quoting himself. So maybe it's less weird if I quote him instead. But shared UI is a history of pain and failure, but shared logic is the history of computers. And I think that's a really just nice description of what Kotlin multi-platform allows. And the kind of Java ecosystem is an interesting proof of this, right? Not everybody is doing things in like JavaFX or Swing UI, obviously, but Java as a runtime runs on all sorts of things as long as it's an environment that can run a virtual machine. And if Kevin can quote himself, I'll quote myself. I first put this in a talk in 2019 sometime. I deeply think that mobile is the killer app for Kotlin multi-platform. There's all sorts of platforms that you can share code between, but Android and iOS are the two that are really trying to do the exact same thing, and can then most benefit from that sharing. In practice, your users don't see Android and iOS apps as two different projects. They see it as the same thing, and they get confused when their friends with an iPhone can do something that they can't do on their Android phone, for example. And I'm not the only one saying that. JetBrains clearly agrees, because they've been putting a lot of effort behind Kotlin multi-platform mobile, which is exactly this use case. This is essentially their it's somewhat of a marketing distinction, but what it really means is they have a dedicated team of product people, developers, testers, etc. That are focused specifically on the mobile use case for Kotlin multi-platform and on stabilizing it and on fixing bugs, etc., and on bringing it to kind of a stable state. So it's currently in alpha, and we hope to see it stabilizing further. So let's talk about shared Kotlin, and the metaphor I like to use is this Venn diagram when I'm thinking about mobile. So on the left side, you have the Android code, essentially the same environment that you're used to running on Android. And some subset of that, you can kind of pull out into this common abstraction. So common code has access to a subset of the standard library, and has access to any multi-platform aware third-party dependencies you have, which then allows that same common logic to get used on iOS, which then also adds, like on the platform side, adds access to iOS specific APIs. So like talking to the SDKs that are part of typical iOS development. And this is not just a like a metaphor. This is literally what the compiler is doing when it builds your apps. Is it takes that Android slice on the left, it takes the common code in the middle, it puts them all together, and it creates the Android library, the AAR, and then it takes that same common code, puts together with the iOS platform specific stuff, and creates a framework, which is the iOS dependency target. And so, yeah, it gives you this really nice system for sharing that code in a way that still looks very native to those platforms, while giving you the dynamic ability to share things between them. So what does this look like in code? Common code, as I said before, like gives you access to like pretty much all of the typical Kotlin niceties that you're used to. So it has like all the language features that you can use in JVM Kotlin. It has most of the standard libraries, so things like collections. You can define classes and functions and blah 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 blah. If that was all you could do, like that would still be like it'd be a little bit of pain to integrate it in spots, but it would still be pretty nice. But luckily, you get a little bit more because you also have the ability to write platform specific things. So one of the things that multi-platform adds to the language is the expecting actual keywords. So you can have a declaration that you define with expect in your common code, and then give separate actual implementations for it on each platform. And if you were at Kevin's talk earlier, he talked a little bit about this and how it's like, it's nice, but you can definitely overuse it, and you definitely want to be kind of deliberate in how you use it. And I definitely agree there. Because when you don't, and like there's things that you can't do essentially. Like it enforces that your actual declarations need to be one-to-one per platform. So if you want to swap out a test dependency, or if you want to kind of give the user a choice of different implementations to use, you don't really have that option. But you do if you have something like an interface. So you could have, say, this logger interface defined in common that might have a Android implementation. It could have an iOS implementation in Kotlin, but with interface, you can even also implement that from Swift. And depending on your team and your workflow, that might be a better option. And then you also get the opportunity to add other implementations. So you could have a test version that lives in common or lives wherever you want it to be. But common is really nice for tests because you could run all of your tests against it on all platforms. And you can do the same thing with function calls that take parameters. You could have like this doing background that you pass from whatever platform you're running on, whatever logic you need to. So with that intro, let's look at what the actual kind of Swift to or Kotlin to Swift boundary interface actually looks like, and some of the kind of hiccups that can come up along the way. And note that like this is from Kotlin to Swift and not from Swift to Kotlin. So Kotlin actually doesn't know anything about Swift. What it knows about is Objective-C. So Kotlin native is able to output Objective-C headers, and then Swift knows how to talk to them. But like you can pass kind of dependencies back down from your Swift, but your Swift doesn't. Your Kotlin doesn't know anything about Swift as a language. So let's suppose we have this person class, and what's actually going to get generated here, and don't worry about all the details, is this pile of Objective-C header. And essentially what this is doing is it defines a shared person interface, which is the kind of Objective-C type that it's using as the equivalent of the Kotlin person. It gives it a init with name, which is the constructor of that person class, and it gives it a name property, which is how it reads the name as a property from the Kotlin class. And that then lets you interact with it from Swift. So there's annotations to take shared person in Objective-C to person in Swift. So you can instantiate your person, you can access its name, access their name, my name. And it behaves like roughly as a Swift developer might expect. So after going through that example, like, let's not worry about the Objective-C details anymore, because that's a huge pile of code that nobody wants to stare at. But what if we want to make some changes to this person? So let's add, say, a nickname field. Maybe I don't want to get called Russell, I want to get called Russ. But not everybody has a nickname. So maybe I don't want to, maybe I want to make it kind of an optional parameter. And we're used to doing that from Kotlin, where we can make something optional, and we can give it a default value of null so that the caller doesn't have to provide it. But when we try to do that from Swift, we get this error. So Swift is still looking for that nickname parameter, even though Kotlin gave it a default. And the reason for that is our old friend Objective-C. Kotlin has the notion of default parameters, and Swift does, but Objective-C does not, and so they don't get bridged through. And what that means is we're forced to either pass that value manually every time, or we could change our Kotlin and define a secondary constructor that doesn't pass the that automatically passes null as the nickname. And this is feels a little bit less elegant when you're used to developing JVM Kotlin, but it's the sort of thing that can be nice when you're trying to expose more pleasant APIs to your iOS side. And there's an analogy there to the early days when people were starting to convert their Java to Kotlin. And there was you'd see a lot of conference talks about how do I write my Kotlin in a way that's nice for Java to consume. And I think we're going to see a lot of the same sorts of topics come up around writing Kotlin that's nice for your Swift developers to consume. So this would be even nicer, of course, if we had a JVM overloads equivalent, so that we could just annotate this class and automatically have it generate that second constructor. But that probably will exist eventually. It doesn't exist right now. So let's look at a couple other examples of things that don't always translate exactly how we might expect. So suppose we have this metrics reporter class that it has this report function that has a couple different overloads that can take different types. And from Kotlin, this behaves kind of nicely as we expect. But when we try to call into it from Swift, we see that one of them has this underscore appended. And what's happening there is essentially, when we're going through the Objective-C bridge, it doesn't allow us to repeat that parameter name inside of the same function name, because it's generating Objective-C functions that have that parameter name as part of the function. And so the Kotlin needs to append this extra underscore to disambiguate that. So it's just sort of a gotcha to watch out for when you're writing APIs that will get consumed on iOS. And you can work around it by just having different names. But it's an argument to kind of be specific enough either in your function names or parameter names so that you don't have too many overloads, so that your Objective-C code, the generated Objective-C code, doesn't end up needing to append those underscores. Another thing that can come up that's a little bit funky is when you have object declarations in Kotlin. So you might have this constants file. There's constants object that holds a bunch of things. On the Swift side, the calling syntax for this is sort of awkward looking. You have this what looks like a constant constructor. What's actually happening under the hood is it's going to return the same instance every time, but the syntax feels weird. They've added a new thing in 1.5.30, so this also gets exposed now as constants.shared.appid, which is feels a little more like what you would typically see from iOS, but it's a little more verbose as well. The other thing you can do is just make it top level, and then you don't get the parentheses or the extra shared you have to call, but you do get this KT on the end. So it's taking the file name, appending KT, and then putting it in that namespace essentially. So this is another example where like it would be nice if we had a JVM name annotation equivalent, so that we could kind of force what this name would be, but doesn't currently exist yet. So just like something to be aware of, that your where like the way that things get called from iOS might look a little bit different than you're expecting from Kotlin. So I'm not going to go through kind of how every type maps between the language, but there's some detailed documentation on the Kotlin Lang website about how like the we had like some strings in that code that we just went through that are getting bridged from the Kotlin string to the Objective-C string to the Objective-C NS string to the Swift string, and there's a lot of details about how the integer types all bridge and things like that. A small note that I won't go into too much detail on is if you're still targeting 32-bit iOS as well as 64-bit, you can run into some funkiness where like certain things map to int on 32-bit systems but long on 64-bit systems, and you have to do some work to work around that. But that's kind of, I think over time that's becoming less and less important as there are fewer and fewer 32-bit devices. But one other piece that is important to think about, and that comes up a lot, is generics. So let's say we have some box class that can have any type of content in it, and we want to talk to that from Swift. So it'd be nice if we could just define like create a box, have kind of type reference, figure out what the thing inside the box is, and in a lot of cases you actually can, but when you're working with primitives or strings from the Swift side, you can't. And the reason for that is that Objective-C sees the type parameter and forces it to be a class type, and like strings and primitives and stuff are value types on the Swift side. So you got this error here, and the way you work around, like the way you can work around that is just by casting. So Swift knows how to bridge directly from its string type to NS string, but you have to actually tell it to do so, because the NS string is what's being exposed from the Objective-C header that comes from Kotlin. But okay, so that's nice. Like we have to do a little bit of that, but now we can read the contents out, right? But it turns out no, we still can't. And so another subtlety of the generics bridging is that Objective-C essentially doesn't know. So Objective-C sees that T type parameter, and it's unbounded. So it could be nullable or it could not be. Objective-C doesn't really have a concept of that, though it's able to kind of annotate around it. But it doesn't know. So even though we've bound that T to a non-null type, when we read out the contents, Objective-C doesn't kind of make the connection to know that T isn't nullable. So if we'd done something like this, then it would work. So if our generic has a non-null upper bound, then we can read things out of that box class and have it and the Swift will know that it's not null. So that's generally a good practice if you're exposing generic arguments to your Swift code. Giving them a non-null upper bound will generally make them easier to work with. Sometimes you don't want that though. Sometimes you actually want it to be nullable. And what I often do there is just have a second version of the class. So if it can be null, have a nullable box that you put it in. If it can't be null, then don't. And that way you get the null safety that you expect from your consuming code. So it's another example where you have to do a little bit of extra work. You have to define this extra class. But once you do, it makes your Kotlin code a little bit nicer. The other thing you might want to do is make an interface out of this instead of a class. Unfortunately, on the Objective-C side, you lose the generics entirely in that case. So the generics can be defined on classes, but they can't be defined on protocols. And so, excuse me. So Kotlin essentially, in its Objective-C headers, totally erases that generic, and you're forced to cast around it manually if you want to use that. So if you are interacting with generics, you should prefer classes to interfaces. Okay, so next up, so concurrency can be its own talk, and it has been. Kevin's done a couple good ones, but a few quick words on it. So Kotlin Native has a fairly restrictive memory model that forces state that crosses threads to be immutable. So there's this sort of either shared or immutable model for it. And there's an API called freeze that you can call to take an object and make it and anything it references permanently immutable and therefore shareable. So this is like nice for the Kotlin team in terms of like it makes it a lot easier to manage the runtime because you know exactly what's shareable and you know that you won't have any weird race conditions. But if you're not used to it, it's complicated to write your application code around, especially because your JVM code might not be structured in a way that's compatible with this. So lots more I could say there, but the only thing I will say is that it's going to change. So there's not an explicit definite timeline on that, but there is a preview in Kotlin 1.6 of their new memory model. So a lot of that complexity is going to be going away. But there's still the question of kind of when that will be. So if you're trying to write code with this stuff right now, you do still need to work with the current model, and you probably will for the next I would say probably for the next year or so, as we're waiting for people to things to adopt the new model. But maybe it'll be sooner. We'll see. Okay, so that was all a lot about kind of how Kotlin things get exposed to Swift. I also want to talk a little bit about the different ways that Swift and Kotlin developers tend to write their code and how that might cause you to want to think about things differently. And the first one that comes up there is kind of how data things are handled. So Kotlin has the data class construct, which gives you that nice generated equals and hash code methods and stuff, makes them behave nicely in collections, et cetera, et cetera. What Swift tends to do is it uses a struct for that use case, which is a value type instead of a reference type, the way most things in Kotlin are. So if your Kotlin code is exposing a data class, it's going to look different to Swift developers than what they might be expecting from their native code. And you can work around this by adding some extensions in your Swift code. So you can create an extension on the Swift version. You could have your Kotlin version manually define a Swift version that has the same information in it, and then define these extensions to convert between them. And if you do that, if you do that and basically run those conversions at your interop boundary, then once you're away from that boundary, things will look much more idiomatic to the Swift developers. Obviously, this is it's a bit of boilerplate. It's kind of, but it is stuff that could be generated pretty easily. It follows a pretty definite pattern, as long as you're careful about what what lives, like what types can live there essentially. There's a lot of opportunity here for some sort of code gen to improve things, whether it comes from the Kotlin team or from a third party thing. Another kind of similar case, or similar sort of in function case, is dealing with CL classes in Kotlin versus Swift enums. So we might have like a result type that has like a success and a failure, and there might be a generic on that success. And Swift would use an enum where Swift has these enums with associated type that allow them to basically be instantiated with different values the way that a subclass of a CL class can be. So if I'm a Swift developer, what I'm used to when I interact with a Swift type is being able to do things like run a switch and have it be exhaustive and not need to write a default case. But when I try to consume the Kotlin one, that doesn't work. Swift does not know that CL class is exhaustive, so that when we've checked these two cases, that we don't need to also check a default case. And like the Swift version gets you this really nice ability to pull out the value of the success and failure types, and like that doesn't translate to Kotlin. That doesn't translate when you're consuming the Kotlin. So you could imagine trying to write similar sorts of extensions to convert between them, and I think that if you're working a lot with CL classes, I think that would be a nice way to go. It gets a little complicated with the generics, and so I'm not showing a code example of that. But it is I think another kind of opportunity for some form of code gen to smooth out that boundary. And then a third example of this sort of thing is kind of dealing with asynchrony in streams. So Kotlin has the coroutines APIs with suspend functions and flows, and that tends to be how Render developers like to expose data from kind of the data layer of their app up through to their UI. But these don't translate well to Swift. So you get some like flow is an interface for one thing, and so the generic gets lost if you expose a flow directly to Swift. And suspend functions do generate a like you can call them from Swift by passing a callback, but you lose all of the kind of Kotlin X level things. So you don't have coroutine scopes, you don't have cancelability. You just have the ability to pass a callback when it finishes. And so it's not quite as rich of an experience as you're used to from the Kotlin side. What you can do to ease this out is kind of write this adapter class to hold the generic, hold the coroutine scope, and give you a subscribe where you can pass callbacks down into it. And then you can kind of wrap your repository in something that exposes that adapter instead of exposing the flow directly. Then it takes a little bit of work also on the iOS side to kind of wrap that adapter into something that iOS is used to consuming. So in this example, we can, and I'm not showing the details of it, but we can wrap it to a publisher, which is the Combine stream type. And that would let us have an iOS repository that looks much more similar to what we might expect from the data layer of an iOS app, where we might be looking at a type that comes up from the Kotlin code, but it doesn't. It's structured in the way that looks a lot more Swifty. And I know that was a whole big pile of code. I have these two blog posts where I kind of go into the details of this pattern, and there's some code samples and some Swift tests if you want to kind of play with it yourself and tweak it and see how it works. So if that's a interesting kind of thing for you, I recommend checking that out. So how are we going to time? Yeah, we can do this. So I'm going to quickly go through. So these were a bunch of kind of abstract examples. I want to go through kind of one fun, maybe not fun, I don't know, recent app that I worked on and needed to kind of think about some of this kind of interop stuff. This was a client where they had this large, complicated web app that they were porting pieces of to mobile. And there was a lot of kind of complicated interaction going on where we had to, like, some of the functionality had to live in web views, some of it was going to live natively. We needed to be able to communicate between them. And there was a lot of platform specific wiring to make that all happen. One piece of that, and there was a bunch of kind of different places where the Kotlin code lives, but one of them was this shared JSON logic that would essentially handle messages going in and out of the web views and like process them and possibly send a response. So we had this kind of message dispatcher class that the web view might call to kind of send something out to the rest of the app. It might return, so it would take the web view would take it in as a string. It would parse it to a JSON object. This handle function was doing a ton of work to and like talking to a bunch of other things to kind of process whatever was happening, possibly send a response. That was nice if you're at the Kotlin layer, because it's using this, like, JSON object is the Kotlin X serialization type that you can use to represent JSON. But it's not how you would naturally talk to it from Swift. And what we ended up being able to build was these two extensions, or these three extensions, I guess. So we had on the Swift side in the native code, we wanted to be able to work with dictionaries, which is kind of Swift's map type, and that's represented in Objective-C as a NS dictionary. And so we were able to build these converters between NS dictionary and JSON object that we could just kind of encapsulate in extension functions, and then create an extension around that dispatcher class to just kind of wrap that conversion. And what that meant in the end is iOS could just pass in its nice kind of map syntax the values that it wanted into that function, which was a really nice way to kind of bridge that shared code in an enigmatic kind of way. So, okay, we've looked at a lot of code, for which I'm very sorry. I know it's the end of a long day. But what are some of the things we've learned? So it's kind of obvious to say it, but Swift and Kotlin are different languages. So we shouldn't expect the interop to be perfect, but it can still be a lot better than writing things twice. And I want to repeat the analogy to when we were writing Kotlin that's very Java aware. I think we can also start to write Kotlin that's very Swift aware, and kind of think about our downstream Swift consumers as we're writing our shared code, and it can make things a lot nicer. And as part of that, like, don't be afraid to kind of add these extra adapter layers to smooth out those interop APIs. Like, this obviously has some cost in terms of runtime, and if you're in a very performance critical space, you'll obviously want to be careful about that. But it's possible to kind of keep like the funky interop code to a thin layer at the interop boundary, and then when you're far away from that, like, your Swift code can just look like Swift code, your Kotlin code can just look like Kotlin code. In all this stuff, there's a whole lot of opportunities for code gen and other bits of tooling to make it nicer. Like, that's a thing to think about if you're thinking about getting into library development, for example. The Kotlin simple processing API just went stable, which means if you want to write essentially an annotation processor that works in Kotlin Multiplatform, you have some assurance of backwards compatibility of that, which is pretty cool. And then there's also people playing with compiler plugins using like the IR plugins, which are less stable but are stabilizing, and there's some cool things that people are starting to do with those too. But on the whole, I really do think the benefits of all of this stuff outweigh the complications. Like, obviously this is my opinion, but I've been working with this stuff for a while, and I think it works pretty well. I think it was Jesse Wilson who said shared code is a superpower, and it's really neat to be able to kind of empower teams that previously were writing these two separate code bases that didn't talk to each other, and they needed to kind of manually keep things in sync. It's really cool to be able to bring that together, to have iOS and Android developers working on the same code base and understanding things in the exact same way. So if you want to dig into more of any of this stuff, here's a couple links. So the first is that doc on Kotlin Objective-C interop and kind of exactly what that looks like if you want to go into the details more there. The next is those blog posts that I wrote on coroutines interop in Swift. If you're generally interested in Kotlin Multiplatform Mobile, there's the landing page for that. And then at TouchLab, we have this sample project called CampKit that, if you're getting into Kotlin Multiplatform for the first time, is definitely a good place to start. So with that, I know we're probably coming close to the end of time, but I would be happy to take some questions. Do we have any come in, Michael?
Yeah, it looks like we have one in the chat, and then I think I had to leave the meeting briefly and I lost a question, but it should be visible to you that was in the chat earlier as well.
What am I seeing? Okay, yeah. So someone asked, do you know of any plan to make Kotlin Swift interoperable without having to go through Objective-C? It's they sort of talked about it in their long-term planning. It's not in their like immediate roadmap. So that the Kotlin team's been putting out these roadmap updates every 6 months roughly for the last year or so. And they have like, here's what we're working on for the next release essentially, and then a couple things that are like in there that they're thinking about a little bit, but are kind of more on the back burner. So direct Swift interop is one of those kind of longer term things that like it is something that they're aware that people want, but it's not going to be here tomorrow. But I think yeah, like it'll one of the things to watch out for with that is it's like it will solve some problems. It'll make some things nicer. It won't necessarily solve everything. So direct Swift interop is not going to save you from the fact that Swift developers use value types and those don't exist in Kotlin, for example. And like some of the generic stuff might get even like could potentially get harder if like most of the Objective-C generics things you can cast around. But when you're within pure Swift code, you're limited in what you can like in how you can cast things. And so if Kotlin is outputting Swift, some of those things might get actually harder to work with. But that's not really clear yet until we actually have a version of it that we can try out. So yeah, next question I see on here is where do you draw the architectural boundary between Kotlin and Swift? So this is definitely something that can vary a lot by team. Like a lot of people ask this kind of question, kind of thinking about what does it look like when I'm starting from scratch and I'm kind of trying to share as much as they can. In that case, you can share it a lot. You can draw that boundary pretty high up. Like people are doing things with sharing from like the view model layer on down, and it can get a little bit funky in the view models depending on exactly how you want to expose things to Swift. And like some of those coroutine interop constructs I was talking about can help with that some. Sometimes it's nicer to be a layer below, like define separate view models so that you can make them kind of more aware of the platform that they're running on. So it depends a little bit on your preferences and on how platform specific the logic within your view models is. But the other thing is like often in practice, you're starting with two existing code bases and you're thinking about like, how can I start to share between them? And there it's a lot more variable where you kind of want to look at like, what is the code that kind of has the most leverage to try to share, whether that's like architectural stuff that we want to be building our next new features with, whether it's like particularly valuable business logic that we want to make sure we write once so that we debug it once, and don't have different bugs on different platforms. It might be it might be I just want to like write my next new features in it, but I'm going to leave everything else that exists alone. So that can kind of vary by team. Do you think there's an opportunity for compiler plugins or KSP to automate, for example, CL classes to Swift enums? Yes, I do. I think the dealing with it in a very robust way is complicated, but it's one of a number of things that I want to start playing with more in the near future. And I think like you might have to be kind of careful about edge cases, or about kind of limiting it to not touch on the edge cases that you don't want to deal with. But I think there's possibilities there. What else is in here? Someone says, from what I'm seeing right now, it's less expensive to just write the code twice than go through all these loops. That will vary depending on what the code is. Like if you're sharing a tiny piece of code, then yes, it might not be worth it. If you're kind of trying to enable yourself to share a lot of new things, then I think it will be. But obviously, again, like that's going to be something that looks different to different teams. Yeah, I think is that it for questions. There's some other discussion in here, but I'm not going to try to read it all live and understand what's coming out of it. Are there any others? I'm not looking at Slack right now, so are there any others in Slack, Michael, that I should answer?
No, I think the Slack questions you can would be answered after, pretty much. Just if you want to engage there.
Sure. Yeah. So I guess with that, like, I'm happy to let's drop the recording. If we
Great.
want.